Now, today we will talk about what is an inverse function. Now, today we will just introduce the inverse function and we will find some basic inverse functions. Now, a function, you can think about it as a machine that has an input and then it gives you an output, where usually the input is the x and the output is the y. Maybe you have seen this in your previous classes. You have a machine here where you put an x, it does something to it, and then it gives you a y. This is the basic main idea of a function. You place an x and you get a y out. Now, what an inverse function does is it goes the opposite way. You will plug a y in and you will get an x that it came from. So that's kind of like the main idea here. So this is the original function, where for a function you place an x, then it does something to it, and then you get a y out. So now an inverse is the opposite. You plug a y in, and then you get an x out. So it's the opposite of an original function. It goes the other way. Now, here, the main idea is that an inverse function is a function that reverses, which is explained here, what the original function did, which is basically going backwards. So let's get some examples going here. Now let's look at the first example here. Here, we're given some coordinate points. And the first task is we need to find the inverse of the following set of coordinates. When you've been given coordinates and you want to find the inverse, all we're doing, we're just flipping signs. So this is the original, which means that the inverse, we're just going to flip them. If my first coordinate is 2, 3, then for the inverse, well, let's actually write down what we're looking for. Here, the inverse, it will be 3, comma 2. If you have an original point of 1, 2, then the inverse is going to be 2, 1. And the same goes for everything. Because again, inverse, it means to go backwards. And in coordinate points, it just means we're flipping its coordinates. So this is the original, which means that the inverse is what we have here. Let's do another quick example here. Look at example 2, real quick here. We want to find the inverse again, right? So let's see what the inverse is. Okay, so let's find the inverse now. Real quick, my first coordinate is 6, 7. So that means that if I want to find the inverse, that would be, we just flip it. So that becomes 7, 6. Second one is 7, 8. So that means that my inverse is going to be 8, 7. And so on. All we're doing is we're just flipping the signs. Because this is what an inverse does. It just gives you the opposite. It gives you where the y value comes from. And when we talk about coordinate points, we just flip signs. But now, it's not always going to be this easy. Let's talk about how can we find inverses when we're actually being given functions here. So to find inverse, when a function is being given, we're going to follow the following steps here. Where the first step is, we want to write the function in terms of y. In Algebra 1, you have seen that f of x, that's the same as just writing it as y. So let's rewrite our original problem. Original problem can be written as y equals for x. All right, so that's pretty much our first step done. Our equation is in terms of y, so we're good. Now the second step is the most important one, because this is what's going to give us the inverse, which is we're going to switch the x and the y values just like we did when we're looking at coordinate points. So now, this is the original. Now for the inverse, we're going to switch them. Whenever you see a y, now that's going to be your x. And whenever you see an x, that's going to be your y. So this is what the second step does. We're just switching x with y's. And now the last step is we got to solve for our new y. So here's our new y. Let's solve it, which is saying we need to divide 4 to both sides. So that means our inverse function is going to be y equals x over 4. And this is our final answer here. But we want to use the correct notation. The notation that we're going to be using for inverses are f with the -1 on top of it. So f -1, that's equal to x over 4. This will be considered your last or your final answer because it's using the correct notation. When we talk about inverse, we got to use the notation of f -1. So now let's look at the second example here. Let's bring down our steps. Again, first step, it's always the same. If it's written in terms of f of x, we want to write it in terms of y. So let's just switch it. So now this becomes y equals 7 minus x to the third. So good. That's our first step. Second step, we're going to switch, which is the most important step, in my opinion. So you see a y, now it gets an x. 7 minus, it's a y, it's an x, now it becomes a y. Let's rewrite that y. Excellent. So we're done with step 2. So now we're going to solve step 3 now. How do we solve for step 3? We got to solve for our new y, which is right here. So the first thing we want to do is take away the 7. So now we have that x minus 7 equals negative y to the third. Before you start solving for y, try to make sure that that y is positive. So let's make it positive by just dividing -1 to both sides. So now we have negative x plus 7 equals y to the third. Excellent. Notice that the y, it's almost by itself. We need to get rid of that exponent of 3. So how do we do that? We take the cube root of 3 to both sides. Because once we do that, the cube root is going to cancel out with the exponent, and now we have our y by itself. Let's just write it here. So now that says that y is equal to the cube root of negative x plus 7. And that's it. This is how you find an inverse function. As long as you follow those 3 steps, everything should be straightforward. Now, let's look at our final example here. Again, we're not going to write the steps here because they're pretty straightforward. The first thing that you should do, just write your equation in terms of y. That f of x can be written as y. So we're done here. All right, second step, switch the x and the y. So now we have that x is equal to 3y. Good. So now we want to solve for that y. So how do we solve for that y? Excuse me. We have a lot of techniques, but once we have the variable that we're looking for as an exponent, we have 2 techniques, the same base and the logarithms. Now here, we cannot use the same base because x you cannot represent as a number, so now it just leaves it as the logarithm. So when you have a variable on the exponent, the easiest way to solve for it is just multiplying log to both sides. We saw this in the previous video. So now we have that the log of x is equal to the log of 3y. Good. Why do we do this? Well, again, when you have an exponent, you can just bring it to the front. So now this becomes log of x equals y times log of 3. And again, What we're doing here is we're solving for y. We're solving for a new y. So how can we solve for a new y? Well, you just gotta divide log to both sides. And finally, we have solved for our new y. So y equals log of x over log of 3. But remember that we need to use the correct notation. So now we're just going to write it as the following. And we're done. Now, one thing that I noticed is that on our second example, we didn't actually wrote the correct notation. So let's go back to it. It is true that this is our final answer, but we got to use the right notation. So our final answer is f negative 1, the cube root of negative x plus 7. So now this is the final answer because we got to use the correct notation. And when we talk about inverses, this is the final answer. Good, excellent. So now, here's your entrance ticket. Just find the inverse for the following functions.